Hello class, my name is Celine from XE Pa Escola Mundial. Today we're going to be reviewing a topic we have previously learned, which is thermophysics. Okay, so let us get started with the definition of thermophysics. So what is thermophysics? Thermophysics is a field of science that deals with heat and temperature. With the study of thermophysics, we are able to calculate the temperature of an object, calculate the linear and volumetric expansion of a solid, explain the process of transferring energy between systems at different temperature, and many more. We are now going to move on into some terms that we are going to meet and use in our topic of thermophysics. Okay, so first we have heat. Heat is defined as energy that transfers between two objects of different temperature, moving from the warmer object to the cooler object. Next, we have thermal energy. Thermal energy is the energy associated with the molecular motion within an object. And finally, we have temperature. Temperature is a measure of the average kinetic energy per molecule, which is used to measure how cold or hot something is. Next, we're going to head into our first subtopic, which is thermometer. So what is thermometer? Basically, thermometer is an instrument that measures temperature. So a thermometer is classified into different classification. First, we have according to use. First, we have clinical thermometer, which is a thermometer used to measure human body temperature. Next, we have laboratory thermometer. It is a thermometer used to measure temperature or temperature changes with high degree of precision. Next, we have atmospheric thermometer. It is a device that measures the temperature of the indoor or outdoor atmosphere. And next, I'm going to show you the next classification of thermometer, which is according to the liquid use. So first we have mercury thermometer. It is used to measure the temperature of the human body. It consists of mercury filled in a glass capillary tube where a temperature scale is marked in degrees Celsius or Fahrenheit. The mercury inside the tube expands or contracts based on the changes in temperature reading. Next, and finally, we have alcohol thermometer. It is a thermometer that utilizes alcohol, which expands or contracts based on the changes in temperature readings. Okay, next we're going to head into our second subtopic, which is units of temperature. So as we already know, there are 5 units of temperature we usually use. First, we have Celsius. It is created or founded by Anders Celsius. It has a freezing point of 0, a boiling point of 100 degrees Celsius, and has a range of 100. Next, we have Fahrenheit. It is founded by Daniel Gabriel Fahrenheit. It has a freezing point of 32 degrees Fahrenheit, a boiling point of 212 degrees Fahrenheit, a range of 180. Next, we have Kelvin. It is founded by Lord Kelvin, has a freezing point of 273 Kelvin, a boiling point of 373 Kelvin, and a range of 100. Next, we have Reaumur. It is created by René-Antoine Frichot de Reaumur. It has a freezing point of 100, a boiling point of 100 degrees Reaumur, and a range of 100. And finally, we have Rankine. It is created or founded by William John McQuarrie Rankine. It has a freezing point of 492 Rankine, boiling point of 672 Rankine, and a range of 180. So these are all the units that we're going to be using as a measure of how cold or hot something is. We can convert the units to each other by using the formula of conversion. This is the formula: T or temperature minus the freezing point over range. Okay, so we're just going to head into our first example so we can understand how to use the formula. So for the first example question, okay, so class, you can pause the video so you can do it by yourself, and pause it and play it again when you already have the answer. Okay, I hope everyone is finished answering. Let us discuss together the answer. So the formula says that it meets the given temperature. So we write down. We write down 79.11 minus the freezing point of Reaumur, which is 0, over the range of Reaumur, which is 100, equals to, so our target unit is Kelvin, so we need to write down the temperature in Kelvin that we don't know. So we empty it out and write TK, or temperature in Kelvin, and then the freezing point of Kelvin, which is 273, and the range of Kelvin, which is 100. We can cancel out the 100, and then what we are left is 79.11 equals to TK, or temperature in Kelvin, minus 273. Now we can just write TK equals to 79.11 plus 273, okay, which is 352.11 Kelvin. Okay, so guys, this is the answer. I hope everyone got it right. Okay, we're going to head to the next example. Convert negative 273 degrees Celsius to Rankine. Okay, pause and play when you're finished. Okay, I hope everyone is finished. So as before, we write down our given temperature, which is negative 273, minus the freezing point of Celsius, which is 0. And then the range is 100, equals to our temperature in Rankine, which is unknown. So we write temperature in Rankine minus the freezing point of Rankine, which is 492, over the range of Rankine, which is 180. So we can write the equation down to something like this: 180 negative 273 equals to 100 times TR minus 492. Okay, so we can calculate 180 times negative 273 equals to negative 49,140 equals to 100 temperature in Rankine minus 49,200. Okay, so 100 temperature in Rankine equals to 60. So temperature in Rankine equals to 60 over 100. This is 3, this is 5, so 3 over 5, or 3 over 5 is 0.6. Now because we use 3 over 5, which is a whole number and it doesn't have a decimal, so we're gonna write it down as 1. This is the final answer. Okay, I hope everyone got it right. Next, let's move on. Let's move on to the next subtopic, which is calorimetry. So, what is calorimetry? Calorimetry is the act of measuring changes in state variable of a body for purpose of deriving the heat. It is the process of measuring the amount of heat released or absorbed by a physical or chemical system. There are units of heat that we're going to be using in our topics. First, we have calorie. It is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. Next, we have kilocalorie. It is the amount of energy needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. Next, we have joule. It is the amount of energy needed to raise the temperature of 1 kilogram of water by 1 Kelvin. It is also the SI unit, because the SI unit of mass is kilogram and the SI unit of temperature is Kelvin. Okay, now the final one is British thermal unit. It is the amount of energy needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. Now we're gonna head into the conversion of units. So 1 kilocalorie equals to 1000 calorie. 1 calorie equals to 4.184 joules, and 1 BTU equals to 1055 joules. Okay, so as I've already written here, this is the formula of heat energy. The formula of heat energy equals to mc delta T. M is mass, C is specific heat capacity, and delta T is change in temperature. So we all know what mass, heat energy, and change in temperature is. What is we haven't discussed yet specific heat capacity. So what is it? Specific heat capacity is the amount of heat needed to raise or to lower the temperature of a given mass of a substance by a particular initial temperature. The specific heat capacity of a given substance is the ratio between the rate of change of heat with respect to the given temperature and mass of the substance. Okay, this is a table of specific heat capacity. So like water has a specific heat capacity of 4,186. That means that to raise 1 kilogram and 1 Kelvin of water, water needs to be given 4,186 joules, and it also happens to the rest of the material in the table. Okay, we're gonna move on to our first example question. You have 5 grams of an unknown metal. If after adding 227.7 joules of energy to it, its temperature raises by 115 degrees Celsius, what is the metal's specific heat? Answer should be in kilocalorie over kilogram degree Celsius. Okay, so pause if you pause to answer, and you can play when you're ready. Okay, I hope everyone is ready and answering. Let us try to answer it together. So we should write down the given first. You have 5 grams of an unknown metal, so the mass of the metal is 5 grams. If after adding 227.7 joules of energy, that means the Q, or the heat energy, is 227.7 joules, its temperature raises by 115 degrees Celsius. That means the delta T is 115 degrees Celsius. What is the metal's specific heat? Okay, so what we are being asked about is C. The answer should be in kilocalorie over kilogram degree Celsius. Okay, I see. So first, let us change our units into the target unit. So 5 grams, we need to change into kilogram. So it's 5 times 10 raised to negative 3 kilogram. And then Q, we need to change into kilocalorie. So we have previously learned that 1 calorie equals to 4.184 joules. So first, let's change joule into calorie. This is the solution. 227.7 joules times. So we need to cross out the joule over 1 calorie equals to 4.184 joules. So we can cross out the joule, and then we do division, which gives us 54.42 cal. So our calorie, it needs to be changed into kilocalorie. So we can so 1 calorie equals to 1 kilocalorie equals to 1000 calories. So we write it down as like this. 1 kilocalorie equals to 1000 calorie. This is because we need to cancel out the calories, so we are left with kilocalorie. So it's 54.42 divided by 1000. So it's 55.442 times 10 raised to negative 2. kilocal. Okay, now that we have converted the unit, let's start putting the given into the formula. The formula we're going to be using is the formula Q equals to mc delta T. So we know the Q is 5.442 times 10 raised to negative 2 equals to the M, which is 5 times 10 raised to negative 3 kilogram. The C that we don't know, and delta T, which is 115. Okay, you should do this on your calculator. So we are left with 5.442 times 10 raised to negative 2 over 5 times 10 raised to negative 3 times 115. Okay, so the answer should be 0.09464. Since we have this, which is 4 significant figure, so we're going to write this as 9.464 times 10 raised to negative 2 kilocalorie over kilogram degrees Celsius. So this is the answer. Okay, I hope everyone got it right. Next, let's move on to our next subtopic, which is effects of heat. So heat can change an object in ways. First, we have one of the example is thermal expansion. Thermal expansion is the tendency of matter to change in shape, volume, and area in response to a change in temperature. So first, there are 3 thermal expansion that we are going to study. We have first linear expansion. This is the formula we're going to be using. The change in length equals to alpha, or coefficient of linear expansion, times original length times change in temperature. For the area expansion, change in area equals to 2 alpha times length times delta T. And finally, for the volume expansion, we have delta V, or change in volume, equals to 3 alpha times L times delta T. Note that 2 alpha can be called beta, or coefficient of area expansion, and 3 alpha can be called as gamma, or coefficient of volume expansion. Okay, we're gonna move on to a table of coefficient of linear expansion. This table of coefficient of linear expansion is going to be given on your test. You don't have to memorize it. This is also the same case on the specific heat. You also don't have to memorize the table. It is normally given. So this is just an example on a table of coefficient of linear expansion. Okay, so let's get started on our example questions. A piece of copper wire is 40 centimeters long at 20 degrees Celsius. What will be its length if it is heated to 120 degrees Celsius? Copper coefficient of linear expansion equals to 17 times 10 raised to negative 6 over degrees Celsius. Okay guys, pause the video if you haven't done it yet, and then you can play it when you're done. I hope everyone is finished. Let's get started. Let us write the given first. Piece of copper wire is 40 centimeters long, so the length is 40 centimeters long. At 20 degrees Celsius, so the initial temperature is 20 degrees Celsius. Heated to 100. Okay, so the final temperature is 120 degrees Celsius. Copper coefficient of linear expansion, so we can write it also down. Alpha equals to 17 times 10 raised to negative 6 over degrees Celsius. So this is a simple question. You just have to write down, fill in the needed things from the formula. Solution, let's write solution. So the change, delta L equals to alpha times L times delta T. So what will be its length? Okay, so delta L equals to the alpha, which is 17 times 10 raised to negative 6 over degrees Celsius times the initial length, which is 40 centimeters, the temperature, which is the delta T is the final temperature minus the initial temperature. So 120 minus 20 is 100 degrees Celsius. So this times 100 degrees Celsius. So guys, do it in your calculator. So the answer is 0.068 centimeter. But our question is, what will be its length if it is heated to 120 degrees Celsius? So it's asking for the final length. So what we're supposed to do is add initial length to the change of length, which is 40 plus 0.068, which is 40.068. Okay, so this is the answer in centimeters. Okay, let's move on to our next subtopic, which is thermal equilibrium. Okay, so what is thermal equilibrium? This is a diagram of thermal equilibrium. It is observed when a higher temperature object when it is in contact with a lower temperature object, it will transfer heat to the lower temperature object. The objects will approach the same temperature, and in the absence of loss to other objects, they will remain in constant temperature. And this is what thermal equilibrium is. So basically, thermal equilibrium is a state of a system in which all parts are at the same temperature. So, for example, let's say we have ice and we wanted to find out how much heat we need to give it so that it can change into liquid. We cannot use Q equals to MC delta T only, because there's Q equals to MC delta T is only how many heat is needed to change from one temperature to another temperature. We haven't added the heat needed so that the ice change shape into a liquid or water. And that is why we are introduced to latent heat. Latent heat, so there are two latent heat. There are latent heat of fusion and latent heat of vaporization. So latent heat of fusion is where temperature remains constant as solid turns to liquid, while vaporization is when temperature remains constant as liquid turns to gas. So this is the formula. When we need to find out how much heat energy needed to change solids to liquid, we can use this one formula, which is heat energy for fusion. I think we have it switched right here. This is supposed to be F for fusion, and this is supposed to be V. So the heat of energy used for fusion is equal to mass times latent heat of fusion. And for when we need to find out how much heat energy needed to change liquid to vapor, we can use the mass times the latent heat of vaporization. Okay, so let's just get right into our example question so we can use the formula we are given just now. If 200 grams of water at 40 degrees Celsius are mixed with 100 grams of water at 10 degrees Celsius and no energy is lost, what is the final temperature of the mixture? Specific heat of water is 4,180 joules per kilogram degrees Celsius. Okay, you guys can pause the video and play when you're ready. Okay, I hope everyone is ready. Let's answer together. So let's write the given first. Given the mass of water, so both are water, so mass of material 1 of water 1 is 200 grams, and initial temperature of 40 degrees Celsius, and our second mass of water is 100 grams, and it has a temperature of 10 degrees Celsius. And no energy is lost. What is the final temperature of the mixture? So, because it's in equilibrium, heat gain equals to heat loss. So, we just need to write down MC delta T equals to MC delta T. So, for the first one, which is the one that is given, so this is the heat loss. Okay, this is the heat loss because it is from 40 degrees Celsius and it gives heat to the lower temperature. So the mass is this, we need to change into 0.2 kilogram. So 0.2 times C, which is 4,180, times the change in temperature. So because this is higher, we are giving away heat, so it must be bigger than the final temperature, because when we are giving heat, it gets lower because the heat is reduced. Equals to wait, maybe we should move this. Okay, so M is 0.2, C is 4180, delta T is now 4D minus the final temperature equals to the mass of the second one, which is this is 0.1 kilogram, 0.1 times 4180 times. So the delta T on this one, because this is the one receiving, it must be the final temperature must be higher than the lower temperature water, because it's going to be receiving heat or temperature. So final temperature minus minus 10. Yeah, that's it. So now we can just do the equation. 0.2, so we can just cross this out. 0.2 and this is 1/2, so we can just times this. So 80 minus 2, final temperature, then final temperature minus 10. So we just move this here and this here. So 90 equals to 3. Final temperature is 30 degrees Celsius. Okay, so this is the answer, guys. And that is actually it for my presentation in thermophysics. I hope you learned something today. I hope some of this knowledge I have given is useful. That is it. Thank you so much for listening. Stay safe and see you next time. Thank you. Bye bye.